Welcome to Session 7 of Chapter 2 Boolean Algebra. The topics covered in this video are Boolean Algebra, Logic Gates, and Fundamental Logic Gates. Boolean Algebra is a mathematical discipline that is used for designing digital circuits in a digital computer. This algebra was proposed by an English mathematician, George Boole. These digital circuits are designed and analyzed with the help of logic diagrams. Here is an example of a logic diagram. The basic electronic components in the circuits are graphically represented using logic gates. Each logic gate is itself a basic electronic circuit which takes one or more inputs and gives only one output. So, a logic gate takes one or more inputs and gives only one output. Before going into logic gates, first we will learn more about Boolean algebra. What are Boolean values? Here are some questions in which you have to take logical decisions. Do you have brown eyes? The answer can be a yes or a no. Is it raining? The answer can be yes or no. Is minus 12 less than 5? Once again, the answer can be a yes or a no. We can also replace yes and no with the values true and false. These questions or statements which give the result as true or false are called logical statements or truth statements. The result true or false are called logical values or truth values. In Boolean algebra, the values true and false are called Boolean values. In computers, Boolean value true is represented by the bit 1 and Boolean value false is represented by the bit 0. Therefore, 0 and 1 are the Boolean values. The variables which store the Boolean values are called Boolean variables. Operations in Boolean algebra are called logical operations, and the expressions formed with logical operations are called logical expressions or Boolean expressions. There are three fundamental or basic operations in Boolean algebra: and, or, not. AND operation is represented with a dot symbol, OR operation with a plus symbol, and not with an over bar. Let us write a logical expression with these operations. Y is equal to A or B and not C. That is, Y is equal to A plus B dot C bar. OR is represented with plus symbol, and is replaced with a dot symbol, and the not operation is replaced with an over bar. A truth table represents all possible values of Boolean variables in an expression and all possible results. Let us take the AND operation. The logical or Boolean expression for AND is A and B. That is A dot B. Here A and B are Boolean variables. If Y represents the result of this expression, then the Boolean equation is Y is equal to A dot B. Since Boolean variables can take only Boolean values 0 and 1, the variable A can take value 0 or 1, B can take value 0 or 1. Now let us form the truth table for the AND operation. The inputs are the variables A and B. The output Y is equal to A dot B. Now let us fill in the values for the input variables. When A is 0, B can also be 0. When the value of A is 0, B can be 1. Again, when A is 1, B can be 0. When A is 1, B can also be 1. Look at the input values 0, 0, 0, 1, 1, 0 and 1, 1. There are in total 4 possible combinations of input values. That is, for 2 variables, there are 4 possible combinations, 2 to the power of 2 combinations. Suppose there are 3 variables in an expression, A, B, C. Then there will be 8 possible combinations, that is 2 to the power of 3 combinations. Once again, you take a look at the input values 0, 0, 0, 1, 1, 0, 1, 1. You should always write them in order. You should not jumble them. For that, in the first column, you write 2 zeros and followed by 2 ones. Then in the second column, you put a 0 and then a 1, again 0, 1. Now let us fill in the values for the output y. In the first row, y is equal to 0, 0. That is 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is also 0. 1 and 1 is 1. How did we arrive at these values 0, 0, 0, 1 for output y? Look at this example. Suppose there is a house which you can enter by 2 doors. Let the first door be A and the second door be B. Let y represent the logical statement, can I enter the house? Let closed door have the value 0 and an open door have the value 1. Now door A is closed, so 0. B is also closed, 0. Now what is the value of y? You ask the question, can I enter the house? You cannot enter the house, so y is 0. So the first row in the truth table shows 0 and 0 is 0. Now the door A is closed, so 0. Door B is open, 1. Can I enter the house? No. So value of y is 0. So 0 and 1 is 0. Now the door A is open, so 1. Door B is closed, 0. Can I enter the house? No. So the value of y is 0. So 1 and 0 is 0. The door A is open, 1. Door B is also open, 1. Now can I enter the house? Yes. Yes means 1. So value of y is 1. So 1 and 1 is 1. The output is 1 only if both the inputs are 1. Otherwise, the output is 0. This is the truth table of AND operation. Here you can see the circuit diagram of AND operation, which has 2 switches connected in series. This circuit is symbolically represented by the AND gate. When 2 low signals are given to this gate, it gives the output as low. When a low signal and a high signal are given, it gives the output as low. When a high signal and a low signal are given, the AND gate gives the output low. And lastly, when a high signal and high signal are given, the output of the AND gate is also high. Now let us see the OR operation. The logical or Boolean expression for OR is A or B, that is A plus B. If y represents the result of this expression, then the Boolean equation is y is equal to A plus B. Now let us form the truth table for OR operation. The inputs for the variables A and B are 0, 0, 0, 1, 1, 0 and 1, 1. The output y is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1 and 1 plus 1 is 1. So how did we arrive at these output values for y? Let us see an example. Suppose there are two doors to enter this house. One is a front door and another is a back door. Let A represent the front door and the back door be B. Let Y represent the logical statement, can I enter the house? Now door A is closed and door B is also closed. So A is 0, B is 0. And what is the value of Y? Can I enter the house? No. So Y is 0. So in the first row of the truth table, you have 0 or 0 if 0. Next, door A is closed, 0. Door B is open, so 1. Can I enter the house? Yes, I can enter the house through the back door. So value of Y is 1. So in the truth table, 0 or 1 is 1. Now door A is open, so 1. Door B is closed, so 0. Can I enter the house? Yes, I can enter through the front door. So value of Y is 1. So in the truth table, 1 or 0 is 1. Now door A is open, 1. So door B is also open, 1. So Y is 1 because I can enter the house through either of the doors. So in the truth table, 1 or 1 is 1. The output is 1 if one or both the inputs is 1, otherwise the output is 0. So this is the truth table for the OR operation. Now you can take a look at the circuit for OR operation. There are two switches connected in parallel. And this is the OR gate, which represents the circuit. When both the signals are low, the output is low. When A is low and B is high, the output is 1. When A is high and B has low signal, then the output of OR gate is again 1. When both the signals are high, A and B are high, the result A plus B is high. Next, let us see the NOT operation. The logical or Boolean expression for NOT is NOT A, that is A bar. A bar is sometimes written as A dash or A complement. If Y represents the result of this expression, then the Boolean equation is Y is equal to A bar. Now let us form the truth table for A bar. The input A is having value 0 or 1. Note that there is only one input because NOT operation is a unary operation. It takes only one variable. The output Y is as follows. When A is 0, A bar is 1. And when A is 1, A bar is 0 because Y is the complement of the input. So here you see in this example, when A is 0, y is a bar, so y is 1. And in the truth table also you can see that a is 0 and a bar is 1. Same way, when a is 1, then y is 0. So when the input is 1, the output is 0. The output is the opposite or complement of the input. So this is the truth table of NOT gate, and now you can see the circuit of NOT operation, and here is the NOT gate. So when a is 0, a bar is 1, and when there is a high input, the output is low. So there are three fundamental Boolean operations, AND, OR, and NOT, and their corresponding logic gates and truth table are as follows. So this is the AND gate and the AND truth table, OR gate and its truth table, NOT gate and its truth table. In the next session, we will see more logic gates called derived gates. That's all in this session. Thank you.